18. A world without language barriers. When understanding became instant, the prediction, what we thought. As the internet promised to connect the world, a natural companion idea followed. Language itself would stop being a barrier. Computers would listen to speech in one language, translate it instantly, and speak it back in another. Conversations across borders would become frictionless. Travel would be easier, commerce would expand, cultural exchange would accelerate. The need to learn foreign languages, at least for basic communication, would diminish. In this future, misunderstanding caused by language would be a technical problem, not a human limitation. Standing in 1999, this sounded ambitious but logical. If computers could process text and recognize speech, why wouldn't they translate meaning in real time? Why this prediction made sense in 1999? To appreciate how bold real-time translation sounded, it helps to remember how manual translation still was at the end of the 20th century. In 1999, translation was slow and expensive. Dictionaries were physical or CD-ROM based. Machine translation existed, but was clumsy and literal. Real-time speech translation was largely science fiction. And yet progress was visible. Statistical machine translation was emerging. Speech recognition, though imperfect, worked in controlled settings. Computing power was increasing rapidly. Globalization was accelerating, creating strong incentives to bridge language gaps. From the millennium-era perspective, translation felt like a solvable engineering problem. Languages had rules. Grammar could be modeled. With enough data and processing power, machines would eventually map meaning accurately enough for everyday use. This belief also fit the hopeful tone of the time. A world without language barriers sounded not just efficient, but humane. Communication would become more equal. Access to information would broaden. The internet would speak to everyone. For younger readers today, it's important to note how transformative even partial translation would have seemed in 1999. Simply understanding signs, menus, or basic conversation abroad without preparation felt magical. Who said it, and where? Among the most confident voices predicting this future was Ray Kurzweil, who argued in The Age of Spiritual Machines, 1999, that real-time language translation would arrive by around 2009. Kurzweil believed that exponential growth in computing power and data would make it possible for machines to understand speech and translate meaning quickly, enough for conversational use. Translation, in his view, was another milestone on the path toward more human-like intelligence. At the time, this prediction sounded aggressive, but not absurd. Kurzweil had a reputation for precise timelines, and language translation appeared easier than other challenges like general intelligence or consciousness. What actually happened 2000 to 2025? Real-time translation arrived, gradually, then suddenly. The early 2000s delivered incremental improvements. Text translation improved first. Phrase-based systems became usable. Online translation tools reduced friction, even if results were awkward. The real breakthrough came later, with the rise of machine learning and neural networks. By the 2010s, text translation became fast and surprisingly accurate. Speech recognition reached practical reliability. Translation apps moved onto mobile devices. By the early 2020s, real-time speech translation became a mainstream feature. People could speak into phones and hear translated responses seconds later. Conversations across languages became feasible without intermediaries. By 2025, travelers routinely relied on instant translation. Businesses conducted multilingual meetings with AI assistants. Language barriers were lowered dramatically for everyday communication. Translation was no longer perfect, but it was good enough, and good enough changed behavior. The future delivered the prediction, even if it arrived later than originally forecast. Verdict. Status. Realized. Real-time translation is now widely available and routinely used. While imperfect, it effectively removes language barriers for basic communication, travel, commerce, and collaboration. The core promise, that machines would enable instant understanding across languages, has been fulfilled. Why it played out this way? This prediction succeeded because it benefited from scale. Language translation thrives on data. The internet generated massive multilingual corpora. Machine learning transformed how meaning could be modeled. Once enough examples existed, systems improved rapidly. It also helped that translation did not require perfect understanding, only sufficient clarity to communicate intent. Humans are remarkably good at filling gaps. Machines didn't need to be flawless to be useful. What Kurzweil underestimated was timing. Speech, nuance, idioms, and cultural context proved harder than expected. Progress stalled until new architectures emerged. Once they did, adoption was swift. What this prediction teaches us about the future. This case illustrates a recurring pattern. Predictions about language take longer than expected, but deliver massive impact once they arrive. Language is deeply human and context-dependent. But when machines finally cross a usability threshold, the effects ripple outward quickly. In 1999, a world without language barriers felt aspirational. In 2026, it feels routine, if still imperfect. The future didn't erase language. It made translation invisible. One sentence takeaway. We predicted a world where language wouldn't stop conversation, and ended up carrying translators in our pockets.